Hey guys, welcome to the very first episode of Audio Busters. My name's Michelle, and we've got an awesome episode in store for you today. Let's check it out. Gnarly. That's right, guys. It's all things acoustics today. Our team is going to try and discover the physics behind acoustics. Basically, we're going to define what acoustics is. We're going to determine if actual sound waves are manipulated or changed in a varying environment. And we're going to be doing this with our very own Anna Castellet. She'll be singing one song in the same place at the same time, but in different rooms. Will it change the sound? We'll find out.
Thanks, Michelle. You look lovely today. What are acoustics? They are the scientific study of sound generation, transmission, and reception. What is sound? Sound is a physical vibration that can't be heard. How does sound travel? Energy is transferred from particle to particle, creating a pressure wave. As particles bounce apart, they create a rarefaction. When they are pressed together, they create a compression. Here is a chart. It's not that pretty, but let's get to Anna's voice. It's prettier than this chart. Take it away.
Today I don't feel like doing anything. I just wanna lay in my bed.
All right, guys, so you just heard the very first location that we were at. Please keep in mind try and remember the sound that you just heard. We are now in another undisclosed location in a bathroom, somebody's bathroom, I'm not sure whose, but try and keep in mind now for the next segment of what you're hearing. And is there any difference or not? We'll find out. Anna, take it away.
Today I don't feel like doing anything. I just wanna lay in my bed.
Okay, guys, we've just broken into someone else's apartment. Don't know whose it is. We're in their closet now. It's a bit stinky. I think I know why now. Okay, this is location number 3. Try and keep in mind of the last 2 sounds you guys have heard from the last 2 locations. This is the very last one. We're going to get Anna to sing for us now. Anna, take it away.
Today I don't feel like doing anything. I just wanna lay in my bed.
Science! All right, guys, we hope you enjoyed our experiment here at Audio Busters. You have just heard 3 different sounds from 3 different locations from our beautiful Anna Castellet. She was singing the same lines, and we're wondering if you guys at home have actually heard any of the differences in the audio clips that we have just shown you. We believe we've seen it. This is Dr. Dirty Diana David. She's a physicist here at Full Sail. She's going to discuss with me and help me understand, and you at home, why we've heard those different sounds at those different locations. And a lot of that's got to do with the principle of acoustics. So let's start with the first room in the hallway, Diana. What's happened there?
Well, in the hallway there was long parallel walls with open stairways at each end, causing the singer's voice to reflect on the walls, several times combining and creating reverberation. This means that the reflections were no longer perceived as distinct echoes. Reverb creates a space emulation, and it gives the idea that the singer is in a big room.
Interesting.
Well, Michelle, in the bathroom, or as you like to call it, the dunny, there was 4 parallel walls. Even though you can hear reverberation, it gives the impression of having more dry signal compared to the first location. This particular environment is made of different materials that not only reflect but absorb the sound waves. Different objects in the room act as diffusers, which are generally used in studios to avoid unwanted echoes and reverberation.
All right, so what you're saying is, because there's walls that are enclosed in the bathroom as opposed to the hallway where it was an open space, the sound waves are not able to travel and reflect as much across the whole, like the hallway was. We have less reflection in the walls of the bathroom because it's more enclosed and it's parallel, but also because of the surroundings of the shower curtain, the towels, the flooring. It was more absorptive in nature compared to outside where there's concrete, which is reflective, right?
Yes, that's correct.
Okay. So let's move on to the closet now. We've obviously heard Anna's voice sounded a lot more in focus. It was a lot more dry and clear, and I couldn't hear any reverb. Could you?
Nope.
All right, so what's going on in the closet? Why did that happen? What is going on there?
The reason for this is because the sound waves produced by a singer travel through the air, and as each molecule collides in the air, the sound wave produced is either absorbed or reflected, depending on its surroundings. Because the sound wave produced by Anna was more absorbed in the closet, the sound became more in focus and dry. This is an ideal situation when recording vocals.
Oh, okay. So we had a lot of absorptive material in the closet. So you're saying that the sound waves couldn't travel along the walls because the walls were covered by absorptive material. Therefore, it cannot really reflect and create reverberation or echo, but instead was absorbed into the clothes. So the sound wave kind of dissipated into the clothes. Right, that makes more sense. And so I guess in the music industry, if we can relate it to this, we have to understand the acoustic principles, like the physics behind acoustics, in order to record very precise vocals. Because if we do want to add reverb or echo to a sound as a sound effect, if we already have reverb in the dry signal that we are meant to have as the original signal, you can start to cloud your mix. It can sound muddy. Is that what you think?
That's exactly it.
Right. So guys, I think what we need to learn here is make sure you understand the acoustic principles, the physics behind it. Walls reflect, sound waves reflect off walls. They create echoes, they create reverberation. It depends what kind of effect you want when you're recording, but make sure that when you are producing music that you measure the walls. You need to calculate how far a sound wave that you're producing is going to continue on and how far do you want it to reflect? Do you want it to reflect at all? All these things we need to think about as musicians in this industry. We hope you've enjoyed this episode of Audio Busters and learned something. Diana, thank you so much for your time. I appreciate it.
No, not a problem.
And Anna, thank you very much. And we will see you guys next time on Audio Busters.